Hi, welcome to the lesson about batch processing. So it's one of two lessons covering a very high level concept of data pipelines. Here we are going to talk about batch processing, and in the next one we are going to talk about streaming processing. So what are the basics of data batch processing? The first one is it applies mostly on data at rest, so data that is written and is not moving at all. So for example, you may think about files you write from a streaming broker, files you write from a relational database, for example. You do the extract, you write them at once, and they are staying on the storage like that. It's not the case for data in motion, in contrast, because data in motion is something that moves in the storage layer. So for example, if you take Apache Kafka and partitions, the data is added to partitions in append-only mode. So in other words, the storage is growing. Here, the storage, which we can think about, for example, files, it's rather static. The second point is batch processing concerns on-demand execution, so something that is scheduled. You can schedule it hourly, daily, weekly, it depends on your business use case, but if you see that you have needs to schedule it, for example, every 15 minutes, it may be a sign that you are working with a very special case of streaming processing, which is kind of near real-time processing. Here is because mostly of the resources creation overhead, having this low latency is not ideal because you may end up with a job during lasting for 5 minutes, but spending 10 other minutes to create the infrastructure to run this job. So keep that in mind and always choose batch processing or streaming processing depending on this execution schedule you are requiring. So as a result of this data at rest and on-demand execution point is high latency. So meaning that you will not use a batch job to detect some real-time fraud detection, for example, scenario. Instead, you rather think about batch processing for things that are less time sensitive. So for example, if you have a daily reporting job to build, to consolidate the sales from yesterday, yeah, that can be fine. Nonetheless, you can still have a streaming version to have real-time view, but you have to know that this version may be approximate because of some streaming issues that are not present in batch processing, like for example late data integration and stuff like that. I will detail more later in the course. So another consequence of these two first points are big data sets. Batch processing will mostly work on the whole bunch of data. So for example, the data accumulated last hour, last day. So natively, automatically, there is a lot of data to process, and the infrastructure you will need to create will not be the same as for streaming jobs that will be most incremental ones, because the data will come, and you will almost roughly process the same volume. And of course, the last point is about data availability. So here the data, because of this high latency, will be available on schedule, on the schedule you define in this demo execution. Whereas in the streaming application, streaming processing, you might have some incremental views that change every minute, every 5 minutes. It's completely fine. And the data is more available to the end users than in the batch processing. But as I said, it might have some data quality issues due to the streaming semantics. And now you can see an example of a batch pipeline. So you can see that we have a schedule, which is daily at 3 a.m. We have our database input. So remember the lesson about data pipelines. We have data processing logic that is tied to this schedule. It's quite important to note that we kind of glue this data processing logic to the schedule. Here we are reading data from yesterday. So every day it will process data from a different day. We can generate daily aggregates, count sums, and write this to the output table in the database storage. And more specifically, the things we have been seeing so far are something we call ETL, so extract, transform, load pipelines, where we have some data extracted, transformed, and loaded to the data sink. More specifically, more technically speaking, you can imagine some Unix commands like copy dir from copy directories to extract data from one place to another, seed to replace upper letters by lowercase letters and write them into a new file, and load to copy this temporary dir to some final output destination. And even more data like even in a more data language, we can consider Apache Spark. So for example, we have JSON data that is read with 2 columns, transformed, so with a sample regex replace, and written as CSV files in a different place. But ETL is not a single paradigm you may use. You may also use something a bit different, which is ELT, extract, load, and transform, where you can see we inverse the transform and load steps. In other words, we are loading data first to the destination, and later we are applying the data transformation logic on top of this data directly. And more concrete vision of ELT is extract, load, transform, load, when you may have some staging area. So staging area is something that is not exposed to the end user, it's only your pipeline that sees this data. So on top of it, so you load input data directly to the staging area, you apply the processing logic, and you load the results to the final destination. So it's an ELT a bit extended with this extra load step and the presence of the staging area. You can see now an example of that. We copy CSV files to some staging table in a relational database. Later on, we are transforming this data with the select from staging statement and loading this transformation result to some final table. And as I said also before, there is a very simple definition of batch pipeline called extract load. So we take data from one point and we load it to another. And now, after all I've presented before, you might ask yourself what to choose and when. So there is no single answer. It always depends on the project. You might have a project which is very familiar with SQL transformation, because we see ELT a lot in SQL first workloads. So for example, you take data from files and you load them to some data warehouse and apply the SQL transformation on top of that. But nonetheless, I'm giving you here some pointers. So you can choose ETL when you have some transformation that are not necessarily supported by your data sink. So yeah, if you need some custom code, you can maybe do it with very complex SQL, but believe me, if you need to maintain this pipeline later, the simplicity is always better. And also you may need ETL when you will need to scale your transformation. So you may start a sample project with 10 customers, but maybe 1 year later you will need to integrate 100,000 customers, and your data sink may simply not support this workload. When you use ETL, this transform in the middle is often a data processing framework, which by definition is something which is scalable. On the other hand, ELT involves less operational overhead. So as I said before, ETL involves data processing framework in the middle, infrastructure which comes with it, and in ELT it's all very often limited to 2 kinds of data. So the input, the files, relational database, and the output. And the output you are that has only 1 or maybe 2 data transformation flavors. So SQL very often, and maybe some something we call user-defined functions that you can define with programming language and transform the specific column in the select statements. And finally, there is EL, so extract load, often used only to copy data from one point to another, but you may also need to do some format conversion, and so it may also become a ETL pipeline in the end. So be always careful about this data conversion step. And so when to choose a batch pipeline in general over streaming processing? Generally, batch pipelines are simpler to reason about because all the data you need to process is already available. It's data at rest. If it's, for example, if it's ingested from streaming brokers or from streaming processing, of course, you may have some late data included, but yeah, if you have, for example, 2 hours of latency of late data coming and you have a daily running job, there is a lot of chances that your daily running job will have the complete data to process and generate the final result. So for the operationalization is always very often easier. You have, because of this data at rest specificity, you don't need to worry about a huge volume of late data coming in. You have rather static data set, because it always depends on your business use case, but yeah, it's less dynamic than the streaming one, and it simplifies the reprocessing logic. It simplifies also the monitoring and alerting setup, and as a consequence is more predictable. On the other hand, of course, if you need data very quickly, it's not the ideal solution. As I said before, maybe reasoning about 30 minutes batch jobs it's the best case you might have. Otherwise, it looks very similar to streaming or near real-time processing. And it's quite important also to mention that having batch jobs alone is not enough. You always need the monitoring and, very important, the orchestration layer to simplify all the operationalization or the scheduling, and generally to make your life easier so that you don't need to wake up early in the morning, click on and add the job in the interface somehow. So yeah, with the orchestration is all automated. And there are 2 interesting concepts. So the first one is single point of failure jobs. So the jobs that is in the middle of your batch world, and that provides data to the other jobs. And believe me, if this job fails, you have maybe the morning spent on reprocessing and fixing the bugs and catching up on the late. And there is also something quite similar, but not necessarily. It's the job that should never fail. So the job that should never fail is something that processes maybe huge volume of data. The processing time is long, so for example 1-2 hours, and if it fails, for example, after 1 hour, 1 hour 50, imagine the pain first to find the problem, later to test it, because to test it you might need to reprocess the job on your staging area, or staging environment, integration environment, so it will still take time, and in the end you may have spending whole day on fixing this job that should never fail error. And that's all I wanted to share with you about batch jobs. Now it's time to see what happens with streaming processing. Thanks for watching, and see you in the next lesson.